Hello all. Today's topic of the day is basic stoichiometric calculations. So in this part we'll be discussing about the stoichiometry, how we solve a problem based on this stoichiometric relations. So for that, let's take a reaction. Let's take a hypothetical reaction like AA plus BB is giving us CC and BD, where capital A, capital B, capital C and capital D are the reactants and products, while small a, small b, small c and small d, they are the stoichiometric coefficients. So we'll have a balanced chemical equation. First point, that we should have a balanced chemical equation. Now, this stoichiometry says that the ratio of moles in which the reactants combine or the products are formed is equal to the stoichiometric coefficients, or is equal to the ratio of stoichiometric coefficient. It means if I want to write the ratio of moles of A consumed to the moles of B consumed, that will always be A is to B. Or if I want to find the ratio of moles of A consumed to the moles of C formed, that will always be A is to C. So in general we can write in terms of moles. In terms of moles we can write that small a moles of capital A will react with small b moles of capital B to produce C moles of capital C and D moles of capital D. Let's try to understand with the help of an example. So let's say the reaction which I am having is N2 gas plus H2 gas. It will give us ammonia gas. Now as we can see, this reaction is not a balanced chemical equation. So the first thing will be to balance it. So if we balance it, we'll get N2 plus 3H2 will give us 2NH3. Now we can write the stoichiometric coefficient of N2 is 1, H2 is 3 and NH3 is 2. So moles ratio will be equal to 1 is to 3 is to 2. It means 1 mole of N2 will consume 3 mole of H2 to produce 2 moles of NH3. 1 mole of N2 will combine with 3 moles of H2 to produce 2 moles of NH3. Now let's say I am having 2 moles of N2. So as 1 reacts with 3, 2 will react with 6 moles of H2. And how much it will produce? So we can see 1 mole of N2 produces 2 moles of NH3. So 2 moles of N2 will produce 4 moles of NH3. Same way, let's say we are having 5 moles of N2. So with this 5 moles of N2, how many moles of H2 will be required? So as we know, 1 mole of N2 will require 3 moles of H2. So 5 mole of N2 should require 15 moles of H2. And in the same manner, we can see 1 mole of N2 produces 2 moles of NH3. So 5 moles of N2 will produce 10 moles of NH3. So if we know the moles of any one of the component, then we can find the moles of other species. Let's take few more examples. Let's say we are having 12 moles of H2. We are having 12 moles of H2. So how many moles of N2 will be required? So we know 3 moles of H2 requires 1 mole of N2. So same way 12 moles of H2 will require 4 moles of N2. And we know 3 moles of H2 produces 2 moles of NH3. So 12 moles of H2 should produce 8 moles of NH3. So we can see that if you know the moles of H2, we can also find the moles of N2 and NH3. In the same manner, if we have number of molecules of the species, so ratio of molecules is also equal to the ratio of stoichiometric coefficient. It means a molecule of capital A will combine with B molecule of capital B to produce C molecule of capital C and D molecule of capital D. And in the same manner for gaseous reaction, especially for gaseous reaction or gaseous components, we can also write the ratio of volume, and the ratio of volume will also be equal to the ratio of stoichiometric coefficient, which means A liters of capital A will combine with small b liters of capital B to produce small c liters of capital C and small d liters of capital D. It means if we write the volume X relation for the same equation, we'll get 1 liter of N2 will react with 3 liters of H2 to produce 2 liters of NH3. 1 liter of N2 will combine with 3 liters of H2 to produce 2 liters of NH3. Same way, let's say if I'm having 10 liters of NH3. So 10 liters of NH3 will be produced from how many moles of N2 and H2? So 2 liters of NH3 is produced from 1 liter of N2. So 10 liter of NH3 will be produced from 5 liter of N2. And this 10 liter of NH3 will be produced from 15 liters of H2. So this is simple stoichiometric calculation that they will give the moles, volumes or number of molecules of one component, and from that you have to find the number of moles or volume of other components. Let's take few more examples based on the same concept. Example. So let's say we are having CaCO3 solid. On heating it is giving us CaO solid plus CO2 gas. Question 1. They have given 2 moles of calcium carbonate is undergoing thermal decomposition. Find the moles of calcium oxide and CO2 produced. So the reaction we know it is CaCO3 giving us CaO plus CO2, and as we can see this is a balanced equation, so we can write 2 moles of CaCO3 will produce how many moles of CaO? So it will produce 2 moles of CaO and 2 moles of CO2, because 1 mole of calcium carbonate, if you see the coefficient, we'll see 1 mole of calcium carbonate will decompose to produce 1 mole of calcium oxide and 1 mole of carbon dioxide. Second, they can give 100 gram of calcium carbonate is undergoing thermal decomposition. Find the mass of calcium oxide and CO2 produced. Now in this case we have to find the mass. In the previous case moles was given and we had to find moles of the products. In this case mass is given and we have to find the mass of products. So first point, is the ratio of mass is same as that of the ratio of stoichiometric coefficient? So the answer is no. Ratio of mass is not equal to the ratio of stoichiometric coefficient. This point is important. Ratio of mass is not equal to ratio of stoichiometric coefficient. So if they're asking the mass, then how to relate this? So the first thing will be to convert mass into moles. We can relate the number of moles by the stoichiometry. So the first thing will be to find the moles of the given species. So 100 gram of calcium carbonate is equal to 1 mole. How do we find number of moles? So number of moles will be equal to given mass of the species divided by the molar mass. So molar mass of calcium carbonate is 100, so number of moles will be 1. Now 1 mole of calcium carbonate, as per the coefficients we can write, will give 1 mole of calcium oxide and 1 mole of carbon dioxide. Now if we know the moles of calcium oxide, we can find the weight of calcium oxide and we can find the weight of carbon dioxide. Using the same relation, we can write mass will be equal to number of moles times the molar mass. Molar mass of calcium oxide is 56, so 56 into 1 will be 56 gram, and molar mass of carbon dioxide is 44, so 44 into 1, that will be equal to 44 gram. Clear? So for 56 gram of calcium oxide and 44 gram of carbon dioxide will be produced. Now I hope this example is also clear. Now let's take third example. We have a reaction given as H2 gas plus Cl2 gas is giving us 2HCl gas. Question is, find the volume of H2 and Cl2 required to produce 20 liter of HCl. Find the volume of H2 and Cl2 required to produce 20 liter of HCl. So as we can see, this given reaction is a balanced chemical reaction. So the ratio of stoichiometric coefficient will be equal to the ratio of volume. Now from the stoichiometric coefficient we can see that 1 liter of H2 will react with 1 liter of Cl2 to produce 2 liter of HCl. Now they have given, we want 20 liters of HCl. So for formation of 20 liters of HCl, how much H2 and Cl2 is required? So for 2 liters of HCl we need 1 liter of H2. So for 20 liters of HCl we need 10 liters of H2, and same manner we need 10 liter of Cl2. It is just ratio and proportion. 2 liters will be produced from 1 liter of H2. So 20 liter will be produced from 10 liter of H2, and 2 liter of HCl will be produced from 1 liter of Cl2. So 20 liters of HCl will be produced from 10 liter of Cl2. So this is about the basic stoichiometric calculation. I have covered the basic idea with some basic examples. So in this video, this much is enough. In the next coming video, I'll be discussing more about the problems based on the basic stoichiometric coefficients, and we'll discuss another topic also in the upcoming videos. Thank you.